In this video, we're going to learn how to use the inverse properties of logarithmic and exponential functions in order to simplify expressions. So previously we've mentioned that logarithms and exponentials have a very special relationship. And this special relationship is that these two types of functions are actually inverse functions. So we know, multiplication and division undo each other. They're inverses. We also know that, squaring something and square rooting something, they're inverses. If you have a logarithm and you have an exponential that have the same base, they are going to undo each other. So if you see here, we've mentioned like the definition of inverse, and you'll see that we say, okay, g of f of x, so if we put log base b, so notice same base log with same base exponent, they cancel out and we are left with just whatever is in our exponent. Same thing here, if we have an exponent with base b and a log with base b, we are left with whatever is in the logarithm. So it's a really cool relationship that we can use to help us not only simplify expressions, but eventually will help us solve equations that involve exponentials and logarithms as well. So a couple of things you need to know before we get going with these examples. It says if a log has no base number, so if it's just, log and then it has an x inside of it, there's no base down here that you can see. The most common base of a log, that's log, is a base of 10. So if there's no base listed, you can simply assume that this is log base 10 of x. So you can add that piece in so you can see what the base of the log is. We only actually typically write the number of the log if it's something other than 10. Otherwise, we assume that it is 10. The natural log, so the ln feature that you see on your calculator, has a base of e. So that's why the ln and the e have the same button on your calculator, just using the second button, because they are essentially how we find the inverses of each of them. You have base e going on with the natural log, and then you'd have base e in your exponent, and those would be inverses. So what this inverse function property essentially allows us to do is if we have something like, let's say, log base 6, and then we have 6 to the power of x inside of the log. What we can do is, because we have log base 6 and an exponent with a base of 6, this can just equal x. You essentially take what's in the exponent, and that's all that's left, because the log and the exponent undo each other, and we're left with what is left in that exponent. Another cool thing that we can do is say you have something like, 7 to the power of log base 7, and then say we even have, 2x plus 1 inside of here. Well, we can see here that we have an exponent of base 7 and a log of base 7, so those cancel each other out, and we're simply left with 2x plus 1. So we're going to use this property to our advantage in order to help us simplify expressions, because if we can get something that has the same base for the exponent and the same base for the log, then we can essentially undo the logarithm and the exponential, and we're just left with whatever is either inside the exponent or inside of the logarithm, depending on which one is inside of each other. So here we're going to simplify the expressions by using these inverse properties. So here I notice that I have 10 to the power of log of 4. Now remember, a log with no number is really a log of base 10. So here, because I can see that I have an exponential or an exponent with a base of 10, and I can see I have a log of 10, what's going to happen is those are going to undo each other, and I'm left with whatever is inside of this log here, which is 4. So it really is as simple as that. We can undo logarithms and exponentials if they have the same base. Then if we look here, what I notice is I have log base 5 and then 25 to the power of x. Now what I notice right off the bat is that these do not have the same base. But what I know is I can actually rewrite 25 as a base of 5. So we're going to do some rewriting here. So here we have log of base 5. That's not going to change, But what I'm going to do here is I'm going to change this 25 to be 5 squared. So notice that I just rewrote 25. I kept the x on the outside of that 5 squared so that I didn't get confused. And I rewrote 25 as 5 squared. Now, we've used exponent properties a couple of different times before. We know if we have powers raised to powers, that this is really log base 5 of 2 times x is 5 to the power of 2x. So we're going to have to do some rewriting here so that we can eventually have a log and an exponent with the same base. Once a log and an exponent have the same base, they undo each other and we're simply left with what's left in this case, the exponent. So again, notice I took 25, rewrote it as 5 squared because I know 5 squared is 25. Use the powers to powers property here to get the 2x and the exponent instead. Then I had common bases, so I was able to undo the logarithm and the exponential together. This next one here, we have log base 2 and then 64 to the power of 3x. So I know that my goal is to get things in terms of 2, pretty much because that's the smaller number. So here I know that 64 can be rewritten as 2 to the power of 6. So I know that piece of it. So now I know that that is all inside of my log. So I rewrote 64 as 2 to the power of 6. Then from here I can use the powers to powers property to multiply those together. So I'm left with log base 2, 2 to the power of 18x. Now I have log base 2 and exponential base 2. Those undo each other and we're simply left with 18x. So again, it's a big rewriting process, making sure you note we rewrote 64 in terms of 2, 2 to the power of 6, used the powers to powers property, and then used those common bases to undo the logarithm with the exponential. Finally here we have e to the power of the natural log. Remember, the base of a natural log is e. So if you need to, you can rewrite this as e natural log base e of 20. It's a little repetitive because you know natural log only will have a base of e, but if you want to visually see it, you can see that you have a common base and a common base, and as a result, those will essentially undo each other, and we're left with simply 20. So just being able to use those inverse properties, strategically rewriting things so you have common bases, and then being able to undo logarithms and exponentials in order to simplify that expression.